Right, now we're going to go through and actually do some examples using the rational zeros theorem. Okay, so right here I have an example. It says determine the maximum number of real zeros and find all potential rational zeros of this polynomial. Now instead of potential I could have said possible there. Either word would work. These are things that could be rational zeros, but they don't have to be. Okay, in fact, most of them probably won't be. So the first thing it says, determine the max number of real zeros. Well, remember, the maximum number of real zeros will always be the degree of the polynomial. You can never have more zeros than you have degree of the polynomial. So the max number of real zeros is 3. Okay, for this particular polynomial, because that's the degree. So now I want to look at all the potential rational zeros. And remember, the potential rational zeros are everything in the form p over q. They're fractions, that's what makes them rational numbers. And the numerator, the p, comes from factors of -6. The denominator, the q, comes from factors of -4. Okay, so I'm looking for all the possible factors of p, or factors of -6. That could be the p-value, the numerator. Well, factors of -6, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. That's a nice list right there. Factors of the leading coefficient that could end up being my q, my denominator. Those are going to be plus or minus 1, plus or minus 2, and plus or minus 4. Okay, those are all of the factors of the leading coefficient. So now the possible rational zeros, again, this is just a list of all the things that I could have as rational zeros. Oops. And we'll call them p over q, where I take the numbers up here on the top and divide them by the numbers down here on the bottom. Okay, so I'm going to go 1 over 1, 1 over 2, 1 over 4. Okay, so I've got, 3 times 2 on each of those, so it'd be 6 possible zeros there. Then I jump over to the 2. It'd be 2 over 1, 2 over 2, 2 over 4. Well, 2 over 1 is 2. Now I do 2 over 2. 2 over 2 reduces to 1, which I already have, so I can skip that one. And 2 over 4 reduces to 1/2, which again I already have, so I can skip that one. Okay, so if you are repeating possible rational zeros, you can skip those. All right, so now we'll jump over to 3. We got 3 over 1, 3 over 2, 3 over 4. Whoops. So 3 over 1 is just 3. So plus minus 3, plus minus 3 over 2, plus minus 3 over 4. And then I jump over to the 6. I get 6 over 1, 6 over 2, 6 over 4. Well, 6 over 1 is 6. Now 6 over 2 reduces down to 3, which I already have, so I'll skip that. And 6 over 4 reduces to 3/2, which I also already have, so I'll skip that. And so this is the entire list. Again, I'm able to narrow it down a little bit by skipping over some of those. All right, it's again a large list, but it will include all of the actual rational zeros. So somewhere in this list, all of the rational zeros occur, okay? Now there will be lots of extra things because I can't have more than 3 rational zeros, 3 real zeros in fact. So at most 3 of these will actually make the function 0. Now I'm not going to go through and find them. My goal in here was just to show you how to find all the possible ones with potential rational zeros. And then we'll go through some other examples in the next video of how to actually plug them in and find all the zeros of a polynomial.